All right, welcome back. 1 week ago, we had sub 25-degree weather, and now it's 50 degrees out. 1 week ago, we were talking about abstraction and encapsulation, and now we're going to move on to the next pillar. Remember that there were 4 pillars in object-oriented programming, other than objects. So sometimes people say that there are 5 pillars. But abstraction, encapsulation, inheritance, and polymorphism. This is something that you're going to be working with tomorrow in your lab, inheritance that is. And it's pretty simple. It's just basically defining a hierarchy of abstractions or of classes, basically. At its heart, inheritance, come on, snap to, there you go, is a mechanism by which objects can be extended. In fact, we use that key word. In Java, we use that key word. And you can extend them to inherit both the state and behavior from its parent class, right, or superclass. Right? So we've got this idea of a parent class. And then down here, that's why we call it inheritance. We've got a child class, a parent class, child class, or sometimes they're called superclass, subclass, right? Whichever metaphor you want, you can use. And/or you can override or augment state and behavior. That is, you can add or modify to provide more specific functionality. Right? Basically, why would you want to do this? It's because in the demonstration I'm going to show you today, if you've got common things in class A and common things in class B, and they're both kind of variations of the same thing, then that means that you should probably, consolidate those common things into one superclass. Just like with functions, if you find yourself cutting and pasting the same piece of code over and over again, that should be screaming out to you, put me into a function so that you can reuse me. If you've got the same state and same behavior, so now we've got same variables and we've got the same functions, right? The functions, methods, whatever you want to call them, and you're using them over and over again, that should be screaming out to you to put them into a class and to separate them out into some sort of a hierarchy. Here's a really quick example. Ignore the covariant, contravariant keywords for now. But basically, this is a kind of a toy example, but you've got a bird up here. A bird is a very generic, abstract notion, right? When I say bird, what comes to mind? Well, any number of dozens of birds that you might be out there. A robin, however, is a specific kind of bird. An ostrich is a specific kind of bird. But they both have feathers, right? They both lay eggs. They have some commonalities that all birds have. A robin, however, is different from an ostrich. How? Robins fly. And how do ostriches move? Can ostriches fly? Nope. They run, right? They or walk if they're not in a hurry. And what's another difference? Size, okay. The one I'm thinking about is one tastes good and one doesn't, right? You can get yourself an ostrich burger by simply going to Fuddruckers, right? Fuddruckers offers ostrich burgers. I don't know about robin burgers, but robins don't taste very good. I imagine they don't taste very good, right? That's where we get the term gamey from. So there are differences between them, but there's more specific behavior, and then there's more abstract behavior, right? Using inheritance allows you to, it provides a way to reuse code, right, on a much larger scale in some sense than just putting something into a function. You can reuse entire classes. And it provides a way to organize code. Right? So going back to this picture, actually let me go to a more complicated picture here. Here's another inheritance hierarchy, something that you're hopefully familiar with. I've demonstrated the use of hash sets and array lists. The rest of this stuff we'll get to eventually. Some of you have asked about tree sets and used it in your first assignment. Great. Good on you for RTMing. and searching out some different smart data structures. But we've actually, behind the scenes, and this is actually a truncated version of this, behind the scenes there's this entire inheritance hierarchy. We've got a collection, which is an abstract notion of a collection. A collection is just a collection that holds stuff. How does it hold stuff? In what manner does it hold stuff, right? Well, then we've got a differentiation. We've got a more specific way of holding stuff. What's the difference between a set and a list? Ordering. A list is ordered and a set is unordered. So we've got more specificity, more specification as we go down in the hierarchy. However, the idea that the collections hold stuff, that's general, right? And so behavior that doesn't depend on anything in the subclasses can be promoted up here to the superclass. Now down here, now we have to start making some decisions. How are we going to hold stuff? Well, over here we're going to hold stuff in an unordered manner. Over here we're going to hold stuff in an ordered manner. Even going down one level further, a set is still just an abstract notion. How are you going to hold your stuff in an unordered manner? Are you going to use a hash table, or are you going to use a tree data structure? Over here with lists, are you going to use an array? That's why we call it an array list. Or are you going to use a bunch of nodes that are connected to each other? Something that we'll talk about later. So, most general down to more specific. It's a way to organize things into a hierarchy. Where else have you seen hierarchies before? King Philip, pyramid schemes. King Philip, what's the rest of it? Kingdom, phylum, genus. We don't remember that. Class, order, et cetera, et cetera. We never remember. Who knows? We're not. But the animal kingdom is split up into this hierarchy, right? We've got kingdoms, we've got phylums, we've got genuses, orders, species, whatever else is down there, right? It's a way of organizing a complex system of ideas. Now, with living things, it's not always that clean. And where does speciation actually differentiate? Is a robin and an ostrich are clearly different species, but dogs, right? Dogs have a lot of different phenotypes, right? There are large dogs, small dogs, different like black dogs, and then spotted dogs, etc. Those are phenotypes and variations within the same species that don't necessarily require this hierarchy to organize them, right? So that is the motivation. Remember, we are online here, so if you have any questions, please go ahead and feel free to post to Piazza, the live Q&A in Piazza. So how does this actually work in Java? In Java, right? Most object-oriented programming languages use inheritance of some kind. Java is a class-based object-oriented programming language, which means that you subclass things. In Java, you use the extends keyword, right? And we say that if A, class A, extends, and I'll put that into code mode there, class B, then A is a superclass, B is the subclass, right? Or parent class, child class, right? Subclass, A is the superclass, B is the subclass. There we go. Sorry, no, that's A extends B. Sorry, let's go back to this picture over here. Set extends collection, so the set would be the child in this parent hierarchy, just like a family tree, and the collection would be the parent class. So this is backwards, and A is the subclass, and B is the superclass. There we go. Okay. All right. In Java, all non-private methods are inherited, and all non-private state can, technically everything is inherited, but whether or not you can see it in the subclass depends on the keyword that you use. All non-private state can be seen by the subclass. All right. So I'm going to demonstrate this in some code over here. So to bring you up to speed here, what I've done is I've created a bank account class. Well, what is a bank account? Well, a bank account is an account number which we've chosen to represent as a string so that you can have account number 123A, which is the example I think I've used. You've got the owner of that bank account. What type is that owner, by the way? It's a person. What is a person? Well, a person is a first name, last name, social security number, date of birth, et cetera, right? Did I put all of that crap over here in the bank account class? No, why? Good composition, right? If you find yourself, what is this entity? Well, this entity is composed of multiple entities. Then it belongs in a class, right? What's another thing that I did with respect to person? A person also has an address. An address is a street, city, state, zip, country, right? We did the, I previewed this last time, and this is what you should be doing as well, right? These 5 strings, that's not a person, right? It's a person's address. And so anytime you say, you find yourself using in English, this thing has this thing, then they are separate things, right? That's composition, right? It's a has-a relationship. With inheritance, what we have is an is-a relationship. A subclass is a or an instance of its superclass, right? So, for example, a robin is a bird, right? An ostrich is a bird, but is a bird necessarily an ostrich? Bird is not necessarily an ostrich, or vice versa, or whatever, right? That's, now let me go back to the figure here and show you the keywords for this idea. A robin is always a bird. That's called covariance, right? It is always safe because a robin can always be treated like a bird. Likewise, ostrich, if I treat that like a bird, well, that's fine because an ostrich is a bird. What I can't necessarily do is a contravariance. If I've got a bird, can I necessarily treat it as an ostrich? No, because it might be a robin, right? And finally, something that is, but it might be the case that this bird that I've got in my hand right now is an ostrich, and so I can treat it like an ostrich. That's not necessarily safe, though, and that's why we call it contravariance. Now, is it ever safe to treat a robin like an ostrich? Or an ostrich like a robin? No, because again, that tastiness comes in. Are you going to eat a robin burger? Probably not. Are you going to eat an ostrich burger? You might. It doesn't taste any different than chicken. Right? Yeah, go to Fuddruckers and you can get yourself an ostrich burger, but you cannot get yourself a robin burger. I don't know if anybody serves a robin burger or not, but whatever. Right? So it follows an is-a relationship, but composition is has-a, right? Let's go over here, back over here to this address. Is a person an address? No, that doesn't sound right. Is an address a person? No, that doesn't sound right either. So we don't have this inheritance relationship between these two concepts of a person and an address. Instead, what we have is a has-a relationship. A person has an address. The way that I've designed it here, does an address have a person? Nope. You can design it that way and have what's called bidirectional composition, where the person has an address and then the address has a reference back to the person, but then you get stuck in this cycle, right? A has B, B has A has B, B has A. And you can get stuck in an infinite loop if you end up doing things like, say, printing stuff out. A person, I'll print the person out. It prints out their address. Well, the address has a person, so let's print out that person. Person has an address. Let's print out that address. Address has that person, and it goes back and forth infinitely. So you do have to be careful if you are going to define bidirectional composition like that. Anyway, back to bank account here. We've got an owner, and we've got a balance here, okay? We've also got a couple of methods here, getters, a constructor. We've got a method here that allows you to deposit an amount. If that amount is negative, of course, that you're not depositing negative $5. If you want to deposit negative $5, you probably mean that you want to withdraw $5. So we throw an illegal argument exception. We also have a withdrawal here. Oops, I never finished this. This dot balance minus equals the amount. There we go. All right. And withdrawals must be positive, of course. There's no point in withdrawing $0 And if you were the amount that if you're trying to draw $100 from a bank account that only has $50 in it, then we'll throw this exception at you. You cannot overdraw this account. Okay? And then a bunch of other stuff here. I've got over here in the demo, I create my address, I create me, and then I create my Fidelity account here that has $50 in it. Okay? There's my birth date, but I'm going to leave that out. Right? No, I was not born on February 30th. Nobody was born on February 30th. But let's go ahead and see that this actually works. Right? And it does. There's my account 1234A, $50 owned by me. Okay? We can work with this account, but what kind of bank account is this? Generic Fidelity bank account. Is there such thing in real life as a bank account? Right? There's a concept of a bank account, but what's one particular type of bank account? A savings account and a checking account. Those are the two most common types of bank accounts. So I want to go ahead and create a checking account and a savings account here. Let me go ahead and create checking account. And I will also, oops, sorry, this should be in that other package. Let me go ahead and drag and drop it over here. Yeah, and get rid of this. So there's my checking account, and here's my savings account. There we go. All right. Well, tell me about a checking account here. Checking account would have an account number, probably, an owner, and a balance. Copy, paste. What about a savings account? Same. Anytime you find yourself doing copy pasta, really rethink what you're doing. Well, in the worst case scenario, you're plagiarizing because you're copying a bunch of code. But not just as bad, but design-wise bad. Anytime you have repeated code, you're violating the DRY principle, the don't repeat yourself principle. Right? If I've got an account number, an owner, and a balance, right, that's common to every bank account. Right? So let's go ahead and get rid of these and rethink this. Okay? What could I do instead in order to not have to repeat all of that state? Not only that, but all of the constructor, all the getters, the deposit and the withdrawal. You can deposit and withdraw from a checking account and from a savings account, right? And then forget about that dead code, right? So what can I do instead? I can make a checking account into just a regular old account. It extends an account, a bank account. Right? Now, there's a problem here, but, oops, I want it right here. That's the syntax for doing it. You've got your class declaration, and then you extend bank account. Right? And now over here in this demonstration, I can make this into a checking account instead, in which case I can write checks, a savings account would pay me interest instead, et cetera, et cetera. Right? So let's go ahead and figure out what this compiler error is. First of all, you have to have a constructor. Right? Let me go ahead and add that constructor. What is it doing? It's calling the superconstructor. Again, let's go back to this diagram here. A robin is a bird. So in order to create a robin in the concept of object-oriented programming, you have to call a constructor on robin. Right? And it could be the default constructor if you really want to. You can define as many constructors as you want. As you saw last week, you had multiple constructors in your lab. But at the same time, a robin, for it to be a bird, the bird things have to be constructed as well. The feathers, anything that's common to an ostrich and a robin, the feathers, the beaks, whatever else is common to birds, they all have to be created as well. And so we are forced to call the superconstructor. And since there's only one superconstructor, I only saw one, you cannot call the no argument superconstructor because it doesn't exist. There. Same thing over here is that I'm going to have to create a constructor because we've got an account number, we've got a person, and we've got a balance here. You do not need a fully qualified, oh, apparently we do. Oh, no, I don't, because I don't want that one. There we go. And same thing over here probably because I drag and dropped it from another package here. You do not generally need this unless it's in a different package, and in which case you would import it up here like you would a normal package. There we go. To do auto-generated constructor, remember, get rid of your dead code. Right? Don't leave those things in your code. That's exactly what I want it to do. Okay. Now I've got this hierarchy where I've got a savings account and a checking account, and they all have commonality. Instead of copy-pasting all of these fields, an account number, an owner, and a balance, and all of this behavior here, now I've got it. Everything. Right? I've got it for free by simply extending the behavior of that other account, and I'll show that to you down here in the demo. That I can go ahead and replace this with savings account. I call it savings account. Yeah, there we go. And everything else is, what's wrong with you? Change constructor to, person. Get rid of this stuff. There we go. Okay, there we go. And now it's fine. It's because it was conflicting between the other sections of code that I was trying to demonstrate. I should have just done this in completely different projects. All right? I could make this into a checking account instead. Right? Of course, I would have to create that checking account. And it's perfectly fine because it still has all the methods that you had before. But now, why do we do this? Well, if all the subclasses are the same, then there's no reason to subclass. If a robin and an ostrich had no distinction between them at all, then why even do this? But they do have distinction. They move differently. They taste differently, right? So, what is our distinction over here in a bank account? The books and libraries in Lab 4 would be an example of inheritance. I don't think so. That's an example of composition. Thank you for that question online. Right. So, what's the difference between a savings account and a checking account?
In a savings account, you accrue higher interest.
Okay. A savings account, you accrue a different level of interest. Right? Let's go ahead, but on checking accounts, you do generally get interest, right? It's just that it's a pittance. Well, frankly, savings accounts are terrible too, but that's because interest rates are terrible. But they do both have interest, they earn interest, but they earn it at different rates. Okay, let's go ahead and implement that. What I'm going to do is I'm going to create a private double APR, right? A ARP APR. That's an annual percentage rate. And for now, I'll just say that, let's say savings accounts are 5% annual interest, which is outstanding right now, right? Versus a checking account, which, I don't know, does anybody have I think that my Fidelity checking account is paying me that's not 1%, that is 0.1%, and I think that that's even high. I think it would be like 0.01% interest. Exactly. So different APRs, that's a difference. But not only that, it could be different on how they calculate their annual interest. So let me go ahead and create another function here, another method, public GetAnnualInterest. Right? Now, the way that interest is compounded is computed is, sometimes especially if it's a credit card, it'll do it on a daily basis. Sometimes on a bi-daily basis. So you get charged. You don't get double charged. It's just that it compounds more, and that means that overall you're paying more. You could, if you do it less frequently, that means that you're paying less on the credit card. Or from the bank's perspective, if they're giving you interest, then they of course want to compound it, say quarterly. Right? So with a checking account, let's say that it compounds quarterly. The formula for doing that is going to be 1 plus the APR divided by 4, because we've got quarterly would be every 3 months. So how many times is it done each year? That's where this comes in. Right? And then we raise that to the power of 4 for quarterly interest. Right? If you don't know finance, that's perfectly fine. This is the APY formula, annual percentage yield. How much do you actually get out of this? And then, of course, we can't use this caret here. We have to use math.pow. Right? And we will raise that value to the power 4. And that's going to be quarterly. Right? And then, of course, we multiply it by this dot balance. Right? This dot get balance. Actually, there's a good question. We need to return this. And we need to return the, specify the type, double. Right? Why did it autocomplete get balance? This dot balance. Nope. I want this dot balance. It's not letting me. Did I lie? Did we in fact not inherit a balance from the bank account? The bank account has a balance, but it is private. What does private mean again? Only the class can see it. In other words, only the bank account class can see this balance variable. An alternative would be to make it public. Is that good? Nope, that's bad encapsulation. You've opened yourself up to the world. You've created a global variable here. All your variables should be private unless you have a very good reason not to do so. This might be a very good reason not to do so. But I don't want it completely public. I want the subclass to see it. I want the robin to see that it has feathers and the types of feathers that are inherited from bird. To do that, we have another keyword called protected. Protected means that the class can see it and all of its subclasses can see it. Right? And when I go over here to the, what was I working on, savings or check? I was working on checking here. Now this is perfectly fine. Right? So, because I've made it protected, now the subclass checking account can actually see it. Half of, or 6 of one, half a dozen of another. I could always go back and make it private again, because I've given the outside world access to it by using that getter function, dot get balance. So, which one? It's the same basic idea, slightly different design. I would generally prefer this though. Right? Again, make things private unless there's a very good reason to do so. This is a somewhat good reason to do so. But if you've got an alternative, like accessing it through a getter, go with that alternative. Right? All right. There we go. And savings account over here has a different behavior. It has APR, higher APR, but also the savings account is done on a monthly basis, say. Right? Monthly, there are 12 months in the year. That's why we divide by 12. If it were daily, it would be 365 instead. 365. Right? So we can leave it like that if we really want to, but different behavior. Right? Now let's go ahead and go over here to the demonstration code, and let's see how much interest I earn on my Fidelity account. System.out.println you get plus my Fidelity account dot, all right, why type when you can just copy paste? Don't do that in general. Get annual interest. There we go. So this is a checking account with only 50 bucks in it. Let's make it $100 just so that the math is more easily verifiable. And ooh, I get a whopping 1 cent out of that, right? Actually, get annual interest should subtract the balance after this, right? It should be, oh, you know what? I think I need in here -1. Oops, -1. Because you don't get you don't get double your balance, right? So maybe I'll fix that over here as well in the savings account. But that was 365 and 365. There we go. All right, now let's go back over to the demo here, and I get a whopping 1 cent out of that whole thing. All right? What if it were a savings account? I'm definitely going to get more. I'm not going to say that it's going to break the bank here at all, but what do I get instead? Ooh, I get $5.12, right? 500 times as much as much interest, right? So there is definitely a difference between these two types of accounts. Some other differences could be that a savings account might have, you know, public, double, get fee. Right? And savings accounts generally don't have fees unless they're high yield savings accounts, right? So we'll return, there's no fee on this, no dollars. Why have something that returns 0? Good question, right? Without doing anything else, I would argue, no, this is kind of a useless function. But let's go over here to checking account. Checking account, unless you maintain a certain balance, say that there's an annual fee of $10, or maybe it's $10 a month, then get a different bank, right? Maybe it's $10 a month and it'd be $120 a year, right? But let's just say that it's $10 a year. Right? Okay, well then what's my net? People have been asking on Lab 5 that have been doing it earlier, what's the difference between gross and net? It's just subtraction. If your gross pay is your pay before taxes and other deductions. Your net pay is what you actually net. Think about it in terms of a fishing net, right? A fishing net you might cast out there and you might catch 10 fish, but as you're pulling it up, 3 fish get away, right? How much did you actually net, right? Instead of just gross. And it's just a calculation, it's just a subtraction, right? So I could ask myself, how much do I actually net with respect to this checking account? Remember, I only got 1 penny in interest, so I'm actually netting negative $9.99, right? It's costing me to have this checking account. Get a different bank, right? This is terrible USA bank or whatever. Right? Although there is a USA bank, there's no terrible USA bank, right? All right, so let me go back to the demonstration here. And in general, you want to treat your subtypes as generically as possible. What I mean by that is, in previous examples, whenever we created a hash set or an array list, we didn't treat them like a hash set or an array list. We treated them like a set and a list. Just to remind you, this is how we generally do it. I have a list of integers, right? My ints, my IDs or whatever you want. New array list, right, of integers. And I'll use the new syntax right here. Right? And of course, I have to bring this in there. I am treating a subtype like it's supertype because I don't care that you're holding stuff in an array. Right? That's abstracted away from me. I don't care about that. I just care that you, where is it? I just care that you hold stuff in an ordered manner. So I'm going to treat you like a list. If I didn't care about the difference between a robin and an ostrich, I just wanted the bird to move, right? Then if I told the bird to move, then the robin would go fly off. If I told the ostrich to move, it would go start running, right? I just want to treat them like birds, especially if I have them in a collection, a flock, right? If I've got 5 robins and 4 ostriches in this collection, I just tell them all to move. I want to tell them all the same thing. Likewise, if I've got multiple accounts over here, right, what I'm going to do is I'm going to create my Fidelity account and then my checking account. And my checking account is not with Fidelity. Say that it's with Wells Fargo. It's difficult to make up mock names. That's why mock data is always difficult. So generally what I do is you choose a theme. Like a TV show or something, and then all of your people are characters in that TV show or something like that. But I think the vast majority of people that turned in the early test cases were just using the tools, and the tools just generated, John Smith, Jane Smith, all that kind of stuff. If you ever actually need to do it by hand, then have fun with it and choose your favorite TV show and go with that. But otherwise, I've got my Fidelity account and my Wells Fargo account. What I want to do is I want to put them into a list. I want all my accounts, my portfolio. I want a list of bank accounts. Why can't I just do savings account or checking account? Well, let's try that. Let's try my checking accounts, my accounts. Right? And that's a new array list. What I'll do is I'll try to my accounts.add. Well, there's no problem in adding my Wells Fargo account over here because it is a checking account. My accounts.add. Can I add my savings account, my Fidelity savings account over here though? No, why? I said that this was a list for checking accounts, right? You can only put checking accounts into this list. I don't want to do that. I want to add up how much interest I'm getting every year. All right, I want to add up that I get the interest from this account and this account. It doesn't matter that they're different types of accounts. All my accounts, give me some interest, even if that interest is $0. Right? So let me go ahead and make this more generic, more general, by treating everything as the super type, treating both robins and ostriches as birds, or treating all bank accounts, checking accounts and savings accounts, as simply just bank accounts. Right? There's my accounts. Now I can add that, and perfectly fine. In fact, what I should do is I should treat both of these, I should treat both of these initially as bank accounts, because I'm not using anything specific to them, except for now something breaks. Get annual interest on my Fidelity account, get annual interest on my Wells Fargo account, right? Those both have get annual interest methods. I just wrote them, right? There's get annual interest in the savings account. There's get annual interest in the checking account. So why can't I do, why did that break? Because now I'm treating them like bank accounts, or I'm treating them like birds. A robin might have a walk method, or no, robins don't walk, robins fly. A robin might have a fly method. An ostrich might have a walk or run method, right? But if I treat them both as birds, now they don't have those methods anymore. I mean, they technically still have those methods. You just can't see them because up here in bird or up here in bank account, do you see? This is the wrong bank account, isn't it? Yep. Let me go to this bank account. Do you see any method here named get annual interest? No. But I do have it in the subclass, and I do have it over here in the subclass, but they're different behaviors. One compounds quarterly, one compounds daily. So what I should do is I should promote this functionality up here to the bank account. Right. Now by default, what interest, how is interest computed in this generic bank account? I have no idea yet. Right. Return -1, because I don't know yet. Right? I don't know what the behavior of this thing should be. But at least it compiles now. At least I can run this stuff, right? Because now checking accounts have this get annual interest, and savings accounts has this get annual interest. What we've done is we've overridden this method. This method is in the superclass, bank account, but down here in the subclass we have overridden the method. We've changed the behavior. Up here it was returning -1 because we didn't know how to handle it. Down here, it's returning this formula, compounded daily. Over there in checking account, it is, I didn't want to do that. Darn it, now I forget how to clear it. Let's just run it. Hopefully that'll do it. All right, darn it. Undo. How do I, coverage? I don't remember how to clear out my coverage. If anybody knows online, let me know. Otherwise, we'll just have to deal with the pretty colors for a while. All right, anyway. In the subclasses, we've overridden these methods. Over here, I have override. Oh, there we go. Just make a change. Override. Somebody had asked about this with the toString method a while ago, and now we kind of have the concept that you can augment or change the behavior to provide more specific behavior in a subclass. In a bird has a move method. How does a robin move? You can override that method to move by flying. In an ostrich, you can override that method to move by walking. In a bank account, you can override that method to do something else entirely. All right? Let's go back over here to make a change. There we go. It goes away. Both of these have get annual interest. That enables me to treat all bank accounts as interest-bearing accounts so that I can, say make a report for each bank account in in my accounts. Right? I can add up the total, double total interest. I'll start that out as 0, and then a dot, what is it, get annual interest? And then I'll add that to my total interest, plus equals. There we go. And I think I've already used A up here somewhere for address, so account, ACCT, there we go. And now now you don't have to print all, I'll print it out down here what my total is. You get totally my total annual interest here. And I'm only able to do this because I've defined a hierarchy where those two things can come together into the same collection, right? You get $5.12 from one, you get 1 cent from another. I should be rounding off to the nearest cent because they don't credit you for fractional cents, certainly in the real world, right? But I've got myself in this hierarchy now. But I do have a new problem, right? I can make a bank account. A generic bank account, A, is equal to new bank account, providing, say, 4444. There we go. I'll just give it a different name there, and then, or a different account number, I should say. Let's go ahead and create a generic bank account, 9999, of $1,500. All right. And I can't use A here. I'll use BA, bank account. Right. Should I be allowed to do this? Remember, BA dot GetAnnualInterest. Is that well defined? I mean, I just threw out -1 as a flag value indicating I don't know how to compute this, because if you've got a checking account, that's done daily. If you've got a savings account, that's done quarterly, right? If you've got a CD, that's done yearly, right? Or a specific type of account, you've got specific type of behavior. But this general bank account, I don't know how to do this. Should I be allowed to create this generic thing and then use it? Should I be allowed to create a generic bird? Can you do that? Well, we can't create. Should I be allowed to genetically engineer a bird? That doesn't make any sense. You can you can raise robins. You can raise ostriches, right? You can raise specific types of birds, but there is no such thing as a bird. This actually gets into the philosophical influence for object-oriented programming. If you've ever heard of Plato and the allegory of the cave, yes? No? I mean, that's pretty common to go over. The allegory of the cave is that humanity is in a dark cave, and they're standing facing a wall, and there's a fire behind them. And so all they ever see is shadows of things, right? Think about it in the following terms. Is there such thing as a perfect circle? Draw a perfect circle, right? Say that you're the best artist in the world. Can even the best artist in the world draw a perfect circle? No. Why? There's always going to be some, error in there. A computer. Can a computer draw a perfect circle on a screen? No. Why? You get down far enough and you see that it's just a collection of pixels. There's no such thing as the perfect circle. It's a mathematical ideal, right? It's an idea. It's an abstract notion. Any circle that we actually see in the real world is just simply one of those dark shadows of it. Likewise, with object-oriented programming, is there such thing as a bird, a class? Is there such thing as a bank account class? Doesn't seem like there should be. Right? That's an abstract notion, in which case you can make what's called an abstract class. Public, abstract, not demo here, sorry. I'm over in bank account. Right? Public, abstract class. Now, what I've done is I've said the notion of a bank account is real. The ideal of a bank account is real. Every bank account has an account number, an owner, and a balance. But there's no such thing as a generic bank account that you should be able to create, because you need to know how to compute interest. Right? You can do that with a particular savings account. You can do that with a particular checking account. But you should not be able to do that with a bank account, because I don't know how to do that. By making it abstract, what I've done here is I've cut off the outside world from doing what I didn't want it to do. By making it abstract, I can no longer create any generic bank account instances. It's not letting me do this anymore. Right? That constructor, I didn't delete the constructor. The constructor is still there. It's still public. People can still see it. They just can't invoke it. They just can't call it. You cannot instantiate the type bank account. Why? Because it's abstract. Right? Just like you can't create a bird, a generic bird, right? It has to be a robin or it has to be an ostrich. And so now I've cut off the world from doing something like this, right? By making it abstract. Now, why would you want to make a class abstract? Well, to prevent people from creating instances of it, but also now you can create abstract methods. Public abstract double. And like I said before, I don't know how to do this. Okay, then don't do it. Okay? What this has done is made this, this method abstract. In other words, I don't know how to do it, but the subclasses, that's your responsibility. Now you can compound that daily, or you can compound that using the APY formula quarterly. Right? But up here in bank account, that's an abstract idea. There are many ways of doing it. I don't know how to do it. I'm not going to make the choice that this is the default way of doing it. Now, I do still have non-abstract methods like setBalance, oh, I lost my withdrawal and my deposit because they were in the other class. Let's do that. I don't want you. I want this stuff. All right, and I'll put it back over here. I don't want setBalance. I want this. All right. I failed to copy paste it from the other one. Right. So I do have non-abstract methods because all bank accounts have the notion of a deposit. Right? There's no difference between depositing to a checking account and a savings account, so why not just put it up here? And it is concrete, right? The antonym of abstract is concrete. It's actually defined here. Right? I don't think we actually say concrete methods, though, in object-oriented programming, but we should, right? Because it's the exact opposite antonym of abstract. Right? But I still have this abstract notion over here. You can have as many abstract classes as you want. You can have as many abstract methods as you want. For example, that other method, like getFee, we can promote that up to the bank account to see how many, and here it might be, you could say, well, that's abstract enough that I don't know how to do it, or you could just say that the default is 0, in which case over here in the savings account, I don't need to override that functionality at all. Right? If you do have default behavior, universal behavior, go ahead and move that up into the superclass. But if you have different behavior, like $10 fee down here, that belongs in the subclass. Most abstract to more concrete, right? The most abstract down here to the least abstract or the most concrete, right? You can go even further. You can create the notion of a bank entity or something like that. And I'm not going to do it with this demonstration because I can't figure out how to do it without it being, you know, just a toy example or something like that. But I do have an example over here in the collections hierarchy. Right? Actually, let's look back at this one. You can't actually create a generic collection. You can't actually create a set. Those are what are called interfaces. And let me zoom out from this smaller hierarchy to this little bit more defined hierarchy over here. Right? There. So ignore the green part for now. All right? Just focus on the blue and the tan part, I guess. And this is basically what we are the same idea as over here, but a little bit zoomed in. Right? These are abstract classes. An abstract collection is a collection that holds stuff, and it actually has some default behavior, well-defined behavior, because you can iterate over all collections. Right? And so it has some method to do that that's universal to it doesn't matter if you've got a list or a set or whatever kind of list or set you have, there's a way to iterate over those collections. Then we've got an abstract set here that adds a little bit more behavior, right, in this hierarchy. Then down here we have a tree set and a hash set. Those are both concrete. Once you get down to the end of this hierarchy here, that's it. That's the end of the road. I mean, you can continue subclassing as much as you want. Then you run into what's called the yo-yo anti-pattern that we'll talk about here in a second. But you can actually create a tree set. You can actually create a hash set, an array list, a linked list. You cannot create a collection, a set, or any of their abstract notions. Again, what you run into is the problem as before. If I wanted to create an actual list, right? Let me go ahead and just do it like this. I can't create a new list because that list is that's abstract. That's an idea of a list. I can't create an abstract list, right? Because it's abstract. Right? Going a little bit further here, the green area is pure abstraction. Those are called interfaces. An abstract class can have concrete methods, like we do in our example, the bank accounts that we do here, and abstract methods. But up here in the interfaces, you only have pure abstraction, no defined functions at all. Right? Let me show you. And again, it's going to end up being a toy example here. New class. No, sorry. I want a new interface. New interface. Mailable, not mailable, but mailable as in we can send them mail. Right? What information do you need to send somebody some mail? Like regular old mail, not email. An address, right? So public static or public address, get mailing address. Actually, just get address. There we go. That's a pure abstraction. Now, you could write here abstract, right? But that's superfluous because this is already an interface. It's not a class, right? So you can put this here, but generally you don't. Public address, get address. Anything that is mailable now is going to be required to have this method called GetAddress that returns an address. So let's go over here to the person class. To make this extend, basically, that a person is mailable because, of course, they have an address, we can go ahead and put this into the hierarchy as well, just like this, this picture over here. These dotted lines, however, use a different keyword. These solid lines right here extend. This class extends this class up here. But an abstract set implements this set over here, that interface. And so I'll show you the syntax here. It is implements. I got to spell it correctly. What did I call it? Mailable interface. And it's perfectly happy here. I do have to bring this in though, right? Oh, it's somewhere else. Oh, darn it! I'm in the wrong person. All right, I want this person class. There we go. And now I don't have to bring it in because it's in the same package. I keep making package mistakes here. There we go. All right. So that means it's already doing it because I've got this, where is it? Get address right here that returns an address. Right? If I didn't have that here though, it would complain. Hey, you said that person implements mailable, but there is no GetAddress class, GetAddress method. Add unimplemented methods. I wonder what that looks like. Right now, the default is to return null, right? But that's obviously not what we want. I'll go ahead and restore this up here. All right. Well, what about an account? Should a checking account be mailable? We mail the person in the checking account, maybe. If we wanted our accounts to be mailable, we could. And our hierarchy would look something like this, where we've got mailable up here as an interface, and our abstract class would implement that interface. Necessarily, then all of our concrete classes would end up having to implement that interface. And that's one of the key differences between an abstract class and a pure abstract class and interface. Okay, you see it right here. If you look at this hierarchy, just the solid lines, right? Then it is a strict inheritance hierarchy. That everything there follows and is a relationship. So if you look at the parent, I don't know why we use these tree metaphors, because usually in computer science our trees are only ever have one parent, right? And so that's what we have here. An abstract class doesn't have an abstract list does not have two parents. Everything only has one parent when you're talking about extending subclasses. However, is that the case with interfaces? No. Look at linked list, right? It has a serializable, clonable, dec, and queue up here. It implements all of those interfaces. So one consequence of the difference between interfaces and abstract classes is abstract classes you can only inherit from one class. But an interface, you can implement as many interfaces as you want. Right? We could, if we wanted, create another interface here. New interface, Nameable. Nameable and name, I don't know. It's not a word, so it doesn't matter how we spell it because it's not a real word. But we could have, like, say, a public string get formatted name. Is there one M? No, there's two M's, right? I don't know. Who cares? Right. And let's make a person nameable. Implements mailable, and now I'm going to have to remember nameable. And I don't think it's like that. Oh, no, it is. Okay, comma. Right, a comma delimited list of things. I thought it was like this, but nope, it is a comma delimited list. And then add unimplemented methods over down here. What does that look like? Well, by default, we're going to return null. I'll go ahead and return this dot last name plus comma space this dot first name. And then we can make our bank accounts nameable. A savings account would be savings account and then followed by the account number. Extends bank account, implements nameable. Nameable. Public string get formatted name. And I could return, well, I could just put this in the toString method. This is kind of useless, but I'm showing you the syntax for doing this. Why is this useless? Because you have this functionality already in toString, right? Return, what is this? Savings account number plus this dot get account number. Yeah. And now we're doing that. Now we're implementing this nameable interface. That's going overboard. Again, I'm just doing this. This is Yagni. You ain't going to need this, right? I'm just doing this to show you the syntax and the concept of it. But you can implement, like in this person class here, you can implement as many as you want. Sometimes this is similar to a concept called mix-ins, where, we'll talk about it in more detail later on, but what is a mix-in? What's that ice cream shop? So ostrich burgers, and then after you're done eating your ostrich burger at Fuddruckers, you go down to Cold Stone, right? Cold Stone, they put, what do they put into it? Here's your ice cream. Oh, nobody's been to Cold Stone?
We haven't gone anywhere in forever.
So they put in mix-ins, right? You've got your chocolate ice cream. I want my chocolate ice cream to also have peanut butter. You mix it in, and now it's chocolate ice cream with peanut butter. I want my chocolate ice cream with peanut butter to also have gummy bears. Okay, terrible choice, but let's go ahead and mix in those gummy bears. And now it's a chocolate ice cream with gummy bears and peanut butter, right? You can mix stuff in. With your classes, you can mix stuff in by making it nameable, making it mailable, right? And you're mixing it in, and that's the kind of the concept. It's not exactly the same in Java because you don't have exactly the same as in a prototype language, but we'll get to that later on. You can implement as many as you want, but you cannot extend multiple. You can't extend bank account and say, I don't know, person, right? You can't do that. You can only extend one class in Java. There are languages that allow you to extend multiple classes, something like C++. And it's a very, very bad idea because then you hit what's called the diamond problem, and we'll talk about that later. Okay. Okay. So that's good for now. Any questions so far on this? Otherwise, that's certainly enough to get you started. Note that we are not started on Lab 5, that is. We are not expecting inheritance in your first phase this Friday. It's okay if you have it, and it's okay to work ahead. We are expecting inheritance on your second phase. So there are multiple types of products, right? Huge hint there that it's probably going to be some subclassing there. But for this first pass, this first phase, we're not looking for inheritance. We are looking for good composition. We're looking for good abstraction. We're looking for good encapsulation. Okay, and of course that it works. Don't forget that part. All right. Oh, thank you. I've been ignoring that. I cannot seem to find the lectures from the 16th. It looks like somebody took care of that. Thank you, Kevin. What is the benefit of overriding an abstract method of the superclass as opposed to just adding a method to the subclass that doesn't exist in the superclass? Good, then you can't treat it like the subclass. If I added, say, let's go over here. If I added a move method down here in Robin, and I treated that Robin like a bird, then I would not be able to use the move method in bird. I would have to define it up in bird in order to make sure that all birds move somehow, right? If I just did it down here in the Robin, then I would never be able to see that unless I only ever have Robins. If I define the move method up here, though, now all birds move. Down here, I can say that it's move, but move by flying. Down here, I can say move by walking. But otherwise, I will not ever have basically a common interface that I can treat all birds as being able to move. I would only ever be able to work with robins, or I would only ever be able to work with checking accounts or just savings accounts, right? I would have to, and over here in my demo class, let's undo that. I would end up having to have two lists, right? If I didn't have a hierarchy, I would have to have list A of savings accounts, list B of checking accounts, and I would never be able to mix those two things together if I didn't have a common interface that all bank accounts have a GetAnnualInterest or GetBalance method. Right. All right. It allows me to treat them all as super types. And in fact, again, going back to this, now that we've got a little bit more under our belts here, review of covariant, contravariant, and invariant. Can I treat a bird like a robin? Sometimes, if you actually have a robin. Can I treat an ostrich like a bird? Can I treat a robin like a bird, though? Yes, that's always safe. Covariance is always safe because this hierarchy defines an is a relationship. A robin is a bird, so you can treat it like a bird. An ostrich is a bird, so you can treat it like a bird. But a bird might be an ostrich or it might be a robin. You can't necessarily treat them like one or the other. And then there's this invariance where if you have a robin, you can't force it to become an ostrich, right? Because it just doesn't work. Over here, likewise, I can treat I can treat a savings account like a bank account. It's super type. But what would happen if I tried to force my Fidelity account, which is a savings account, to become a checking account? Equals my Fidelity account. Can't do that, right? I can't force a checking account to be, or I can't force a savings account to become a checking account unless I do something like this. Does that look familiar? Yep, that looks like typecasting to me. You typecast an integer as a double so that you can do division, right? Double foo bar is equal to 1 divided by n, where n is 10. Right? Is that going to work? No. Why? Because 1 divided by 10, integer divided by an integer is an integer, and so it's not going to, I mean, it's going to end up being 0, right? But I can typecast n temporarily as a double in order for this to work. Likewise, you can try forcing a savings account to become a checking account. Let's find out what happens when I actually run this. Ooh. A savings account cannot be cast to a checking account. Why? That's a class cast exception. That's an invariance. All right? Likewise, I can't I did a covariance in that by taking a savings account or a checking account, whichever one it was. I took a savings account and I promoted it up to its super type, the bank account. But then what I tried to do is I tried to force it to come back down as a contravariance as a checking account. And that's not going to work, right? Because of that invariance. You can't do that. And if you, syntactically you can try to do that, but it's definitely not safe. I hesitate, we have a few minutes here, but I really, really hesitate to show you this because you should not use this in general. But there are a couple of instances where you would want to use it. There is a safe way of doing this. If my fidelity account is instance of, there's no is here, sorry, of checking account, then this is safe. Of course, is that going to be true? Nope. So let's go else system.out. Nope. It is not the safe. This is not a safe operation. It is a contravariance. So now I'll get this message up here instead. This is not a safe operation. It's a contravariance. My fidelity account, which is a bank account, but it's actually a savings account, is not an instance of a checking account. I don't know. I don't think you can do this. No. You just have to say not. No, you can't do something like that either, right? You just have to put it into the else. You might be able to do it like this, because this has got to be a Boolean, right? Yeah, you could do it like something like this, right? Instance of checks. Is this a checking account? If not, then you can't force it to become a checking account. If it is an instance of the checking account, then of course you can force it to be a checking account. I'll get rid of that and that. So, covariance, always safe. Contravariance, it's safe if you look before you leap. Invariance, never safe. Right? You can treat a robin like a bird. Sometimes you can treat a bird like an ostrich if you check to see, is this bird an ostrich? Yep, okay, then treat it like an ostrich. But you can never treat a robin like an ostrich. Okay? All right, any other questions? Yeah.
So for lab 5, on some of the files, it just has a public class and then like hourly employee. Could we change that so if there's like public class, hourly employee extends, blah blah blah?
If you follow the, so good question. Let's go ahead and go to the ER diagram here. There, I can zoom in. So this is the ideal, at least for lab 5. Not necessarily for your project. Your project, there might be different hierarchies. You could define interfaces if you wanted to. There are half a dozen ways of doing the actual project. Some of them are quite wrong. We'll let you know when they're wrong. But some variation is expected and okay. But this one, we're giving you the UML diagram. This is a universal modeling language diagram. And you can see the inheritance here. That a temporary employee extends hourly employee. Hourly employee extends employee, which is abstract. Right? Now, I'm not going to get into the details of UML here, but some tips. You can see the inheritance here, but the arrows here go up though. That's the superclass. Hourly employee is a employee, right? But it's still oriented downward. If the method is normal here, then that means that it's non-abstract. If it is italicized here, you can see that it's abstract because if you really zoom in, what does that A stand for? Abstract. Right? Zoom out here. It also lists all of the constructors. You see over here, anything that is in a superclass is necessarily inherited by the subclass. And since these are all public, which I think green means public, right? And red means private. I'm not sure what protected means, how protected is shown, but probably just yellow right here. But in any case, if you follow the UML diagram and build that hierarchy, then you should be good. Over here, we know that payable is an interface. Why? Because it's this I here. This is an abstract class. Why? C for class, A for abstract. Right? So if you follow the hierarchy, then it should look something like this. So follow up then. What in that context? What's the question?
I was just wondering if you could change it from like public class hourly employee to public class hourly employee extends, so on and so forth.
Extends employee is what you're going to have to do.
Yeah.
Yeah. And note here that this is also abstract, right? Because there's no such thing as an hourly employee. There are temp employees and there are staff employees, but there's no such thing as a generic hourly employee because the way that their taxes are computed is different, right? If I just had hourly employee, I don't know if they're a temp worker and they have zero tax or whatever the business rules are, versus a staff employee where we have to take taxes out. But yeah, you can't extend multiple classes. It has to go up to one. Right? You can multiple children can extend that one class, so you can have as many children as you want, but there's only one parent. So think cell division, not human family trees. Because family trees are a misnomer anyway. It's not a tree. Does anybody know what a mangrove is? It's a whole collection of trees that share a root system, and so it's all messy, right? The roots feeding this tree over here could be 3 trees away, right? And so it's a whole messy root system. It's not a single inheritance hierarchy like Java is, where you can only ever extend from one class. Instead, in a programming language like C++ that does allow something like that, it forms this lattice where you can have, cycles basically, and that's where it leads to the diamond problem that we'll talk about maybe next week. Right? Okay. Definitely enough to get you started. In fact, it's definitely enough to get you started on the second phase of the project that's not due for another 2 weeks plus 3 days. All right.